Imagine a future where robots don't just stand still or perform the same repetitive action forever, but can actually learn new skills, adapt to new places, and help in real homes. This is the world Elon Musk is betting on with Tesla Bot Gen 3, also known as Optimus, and the secret behind it is something he now calls Optimus Academy. It sounds futuristic, almost like a sci-fi training ground, but what this really is gets to the heart of a major shift in how robots are taught to behave in the real world. For decades, robots have learned one way. Engineers program them step by step, or they collect motion capture data that tells the robot exactly what to do, when, and how. That approach works in controlled environments like car factories, but it breaks down the moment a machine leaves the predictable layout of a factory floor and enters a real human household. Houses are messy, unpredictable, different from one to another, and full of tiny variables a simple program can't anticipate. This is where Tesla's Optimus and its training academy come in. Elon Musk has been very clear about the goal. Optimus Gen 3 must be more than a novelty. It must be capable of practical work, not just dancing on a stage or making a viral clip. And the way Tesla is training it is a big part of that story. Instead of programming every task manually, TikTok by TikTok or YouTube tutorial by YouTube tutorial, Optimus learns by observation, just like we do. Tesla engineers have developed systems that allow the robot's neural network to absorb demonstrations and generalize them into skills the robot can execute on its own. What does that mean? It means the robot watches humans perform tasks and then learns to replicate those tasks without needing someone to script every motion. This learning by video model fundamentally changes how quickly and flexibly a humanoid robot can adapt, even in environments the robot hasn't experienced before. In the heart of Tesla's robotics program, the Optimus Academy is making this vision real. According to people familiar with the project, engineers and data collectors perform everyday tasks over and over, lifting cups, carrying objects, wiping surfaces, even dancing, while wearing gear that captures detailed visual data from all angles. This data feeds into the robot's brain, and thanks to breakthroughs in computer vision and neural networks, the robot's AI can begin to understand what actions correspond to what tasks. It doesn't just memorize a sequence of moves, it learns pattern recognition, context, and environmental awareness that helps it decide how and when to act. A big part of this transition has been moving away from older techniques like motion capture suits, remote control, and teleoperation, which were laborious and slow. Tesla engineers realized the future lay in letting Optimus watch humans and learn from them directly, so they shifted to what's called a vision-only training strategy. Instead of having humans direct the robot's limbs through controllers, humans now perform the task naturally in front of cameras, and Tesla's AI uses that footage as training data. This approach is similar to how Tesla's learned to drive autonomously as they watch thousands of real examples and learn patterns from them. This strategy gives Tesla several huge advantages. First, Tesla already has access to massive amounts of video data of humans doing things, not just robots doing things. There are millions of hours of tutorials online showing how to chop vegetables. With the right training systems, Optimus could someday watch that kind of content and transform it into working knowledge. Engineers are already experimenting with feeding first-person and internet video footage into the robot's learning loops. This puts Optimus far ahead of traditional industrial robots that require painstaking manual programming. But learning by watching isn't just about video. Tesla's approach includes simulation environments where Optimus practices tasks virtually before trying them in the real world. This sim-to-real training lets the robot test thousands of variations of an action, analyze what worked and what didn't, and refine its internal models, all before committing any actual real-world motion. These simulations accelerate the training cycle and help Optimus handle rare edge cases it might never see in a classroom setting. These are the kinds of methods that elite autonomous systems use to prepare for unpredictability and complexity. At the same time, Tesla's Academy isn't purely digital. There are real humans training robots in physical spaces too. In Tesla's engineering labs, workers perform the same simple human tasks hundreds of times, so the robot can see them from every angle. These are not glamorous or easy demonstrations. Data collection can be repetitive and even physically demanding. Staff often describe wearing cameras and backpacks for long shifts to produce usable training footage. Tesla itself treats these spaces almost like a glass-walled laboratory where engineers constantly refine both physical movement and AI understanding. But what does Optimus actually learn from all this training? Early demonstrations give a hint. Videos released by Tesla, backed by Musk himself, show Optimus performing chores like vacuuming floors, picking up trash, sweeping, opening cabinets, closing curtains, and even tidying a table. Each of these isn't hard on its own, but stringing them together into reliable, robust performance in an unpredictable environment is a huge leap. And crucially, these skills were learned by watching humans do them, not by painstaking programming. Pottery making and dishwasher loading may look cool in demonstrations, but they aren't the most important part of the story. What really matters is transfer learning, the robot's ability to take what it learned in one situation and apply it to something new. For example, once Optimus understands how to open a fridge and pick up a bowl, that understanding can help it in cooking, serving, or cleaning tasks that share underlying elements. That adaptability is what makes a robot truly useful around humans, not just in tidy factory aisles. The hands are also central to the story. Musk and Tesla engineers have said that making robotic hands that approach the flexibility and nuance of human hands is one of the biggest engineering hurdles. But Genesis 3 is making progress. As hands become more dexterous and capable of fine manipulation, the robot's ability to perform real household tasks increases dramatically. It's one thing to push a button or turn a lever, it's another to gently hold a fragile object or thread a shoelace. Future Tesla bots are expected to improve at these skills through ongoing training, both virtual and real, guided by the same observational learning. Frameworks pioneered at Optimus Academy, and the vision for this training isn't limited to one task at a time. Tesla is building a continuous learning ecosystem where every robot contributes to the collective knowledge base. When one robot masters a skill, that information can help other robots learn faster. In essence, Optimus units could share lessons like humans share knowledge today, only at machine speed and scale. This type of collective intelligence could accelerate robot capabilities far faster than any isolated training approach. There are also social and safety dimensions to this learning process. Training in environments that simulate real interactions, like crowded spaces or homes with children, helps the robot understand not just how to do a task, but when and where it's appropriate. For example, fetching a dish is one thing, but doing it without bumping into a child or a pet requires spatial awareness and social understanding. Real-world training scenarios, reinforced by simulated learning, help bridge this gap. Elon Musk has often said that he sees Optimus as Tesla's biggest product ever, not just another industrial gadget. Whether that claim ends up true remains to be seen, but the training strategy behind Optimus, the Optimus Academy, is undeniably ambitious. It represents a shift from the old way of building robots to a new vision where robots not only execute instructions, but learn from the world around them, much like humans do. If this approach succeeds, the implications are huge. Imagine robots that can reliably help elderly family members with mobility and medication reminders, assist with household chores, provide companionship, or handle day-to-day tasks that eat up our time. Instead of being programmed for one narrow function, robots trained in this way could adapt over years of use, learning from observation and experience just like we do. In the next few years, as Tesla continues rolling out Optimus units and refines the Optimus Academy training pipelines, we may begin to see early adopters put these robots to work in real homes and workplaces. What starts with simple chores could evolve into deeply personal assistance, companionship for the elderly, educational tools for children, or even workforce partners in industries where human labor is scarce. So what would you want Tesla Bot Gen 3 to learn next? Would you want it to help in the kitchen, take care of your garden, or assist your elderly parents? Take a moment and imagine the possibilities, because this isn't science fiction anymore. The era of robots that learn like humans, by watching, observing, and improving, has begun. If you enjoyed this video and want more updates on Tesla, AI, and robotics breakthroughs, hit that like button and subscribe for notifications. Don't forget to share your thoughts in the comments below about what you'd want your own Optimus robot to do. And if you want to dive deeper into the future of technology and how it will change our lives, stay tuned for the next video. We release new insights every week.